All right, welcome back to another video, and today we'll be working the January 2022 paper 2 question 3. If you haven't seen question 1 or 2, you can check the link in the description below and check those out. So question 3 says the box below contains the names of 5 quadrilaterals. So they gave us the trapezium, the rhombus, the the square, and the rectangle. And it says choose the name of one quadrilateral from the box that best completes each statement. So part 1 says a dash has no lines of symmetry and has rotational symmetry of order 1. So what we realize is that for these 5 quadrilaterals, what we're comparing is lines of symmetry and the rotational symmetry of these quadrilaterals. So we know, for example, from this part that says has no lines of symmetry, there are certain quadrilaterals that we can rule out from that statement alone. So for example, if we're looking at our square, not a perfectly drawn one, but a square has 4 lines of symmetry. So this is 1, this is 2, this is 3, and this is 4. So basically, what the line of symmetry is looking at is where on these polygons, or in this case, these quadrilaterals, can I cut this shape and I get 2 perfect halves. So therefore, we know this one cannot be a square. The same thing for a rectangle. Because a rectangle has 2 lines of symmetry. We can cut it here and get 2 perfect halves, and we can cut it here and get 2 perfect halves. Not my best drawing, but that is fine once you understand. The same thing for a rhombus. I always say a rhombus is like a pushed out of shape square. So from that alone, we know that it cannot be. So we can cut it here and we get 2 perfect halves, and we can cut it here and get 2 perfect halves. So therefore, we know so far that square is not our answer, rectangle is not our answer, rhombus is not our answer. And if you remember how a kite shape, we can get 1 line of symmetry from this. So therefore, the only one that we cannot get any line of symmetry from is our trapezoid. So basically, when look at this, there's nowhere on this that we can cut it and get 2 perfect halves where they can fold over. It's like folding a napkin in 2. There's nowhere on this trapezium that we can do that and get 2 perfect halves. So it has no line of symmetry. However, this one rotational symmetry of order 1 that they're speaking to, it's when a full 360 is done. So some teachers will teach that all diagrams have at least 1 rotational symmetry, and other teachers will say if it is only that one where it makes a complete 360, then they're not counting it as 1. And that is why the question now here says choose the one that will give you that best complete the statements. And we're going to go back to that in a while. So for this one, we are choosing the trapezium. Part 2 says a dash has exactly 2 lines of symmetry and 4 right angles. So looking back at our diagram, the only one that has 2 lines of symmetry is our rectangle and our rhombus. However, the other part says it has 4 right angles. The only 2 that would have 4 right angles would either be the square or the rectangle. And the square was already ruled out from 2 lines of symmetry because it has 4. So therefore, answer for part 2 would be rectangle, because a rectangle has 4 right angles and it has 2 lines of symmetry. Part 3 now says a dash has 1 line of symmetry but no rotational symmetry. From 1 line of symmetry, looking back at all our shapes that we did a rough sketch of on our exam paper, the only one that would have 1 line of symmetry is our kite. But this is the part where now we're saying choose the one that best completes its statement. Because if your teacher taught you that every shape has at least 1 order symmetry when it is rotated a full 360 degrees, then when you go in the exam and you see it says it has no order symmetry, so it has no rotational symmetry, then you'll be wondering like, but that's not what my teacher told me. My teacher said every quadrilateral has at least a rotational symmetry of order 1 when it is rotated 360. In this case, we're just going with the one that best completes the statement. And in this case, the one that best completes it is the kite, because it is the only quadrilateral here that has one line of symmetry. So we're doing what will give us our grade 1. So we're looking at kite. We're not going to debate and to say that is not what the teacher told us. So this is just a case where words like best completes fits perfectly and we use it to our advantage. So we're now going to the next question. So it says, the diagram below shows 4 straight lines, 2 of which are parallel. So our parallel lines are the ones that has the arrows. So you see the arrows are going in that direction. So the other 2 lines that cut these parallel lines, they're called transversal lines. So it says determine the values of Q and R. It did not tell us which order we should answer them in. So we're going to answer them in the one that makes us feel comfortable. So first we're going to answer R degrees, because as I look at this paper, I'm like, oh, I remember this one. My teacher taught me it. It is vertically opposite angle. And my teacher said that vertically opposite angles are equal. So therefore, R is vertically opposite to 54 degrees. So therefore, R is 54 degrees because vertically opposite angles are equal. So I'm going to say R is equal to 54 degrees. And if they had asked you for the reason, you can say it is vertically opposite. And now we can look at Q. So if I'm comparing Q degrees and R degrees, I remember you're in the exam and you remember that, wait, my teacher told me that R and Q, they would be co-interior angles, and the co-interior angles add up to 180 degrees. So R degrees plus Q degrees, it would be equal to 180, because co-interior angles are supplementary, and supplementary angles mean that they add up to 180. So I know what R is, which is 54. So it is 54 plus Q is equal to 180. So therefore, to solve for Q, it would be Q is equal to 180 degrees minus 54 degrees, which is equal to 126 degrees. So my answer for Q would be 180 degrees. However, if you're like one of those students where I must solve Q first before I solve for R, what you could have done was to say, if this right here is 54 degrees, then this point here also is 54 degrees. What that is called is corresponding angles. So corresponding angles are equal. So if this is 54 degrees, then this would be 54 degrees. And you can then solve using angle on a straight line. So you could say 180 minus 54, and that would have given you the same 126 degrees that we are looking for. So anyone that you choose, once you're comfortable with your working, then you go right ahead and solve it. Part 2 now says, give a geometrical reason as to why angle P is equal to 71 degrees. And then you're like, wait, I remember this in geometry when my teacher was drawing something from the alphabet and it resembles a Z, and they say when you see Z angles, then these parts, they are equal. So we can say angle P is equal to 71 degrees because what did that teacher say about angles in a Z? They are, because they are because they are alternating angles, and what did they say? Alternating angles are equal. So that is why angle P, so this is our geometrical reason as to why angle P is equal to 71 degrees. Now another question, part C. So it says the diagram below shows triangle x prime, y prime, z prime, and x double prime, y double prime, z double prime drawn on a square grid. Part 1 says triangle x prime, y prime, z prime is the image. So this is an image after an enlargement of scale factor 2 with center 5, 1. And it says draw triangle XYZ, which is the object for triangle x prime, y prime, z prime on the grid. So they gave us two very important information here, which would be our center, which is 5, 1. And the scale factor, which is k, is equal to 2. What this means is that this image is twice the size of the object, which is x, y, z, which they asked us to find. So this image is twice the size of the object. So these are the two important information that was given to us that will help us in deciding where on this graph is our object x, y, z. So there are different methods that you could use. You could use some mathematical equations where we have the coordinates for the image, and what we could do was to first subtract the center of enlargement, and then what we get, we divide it by 2, then add back the center of enlargement, and that would give us where exactly our points are. But today how we're going to do it is to map from each coordinate on the image, from each point on the image to our center of enlargement. I'm going to find the midpoint of one of those lines, and then we're going to work magic. You could also find the midpoint of all 3 lines, and all 3 lines, when you find the midpoint, it would give you what the coordinates of the object is. But that is with 3 different workings, and all they're giving us for it is 2 marks. So what we're going to do is to work smarter, not harder. So this would be our first line, from our y prime to our center enlargement, which is 5, 1. And if you're drawing a line from x prime to the center as well, and then if you're doing the same from z prime to the center. But what we're going to focus on today is from y prime to the center. So those are the 2 coordinates that I will be looking at. So let's get to my work box. So what we're looking at is the midpoint is equal to, so it will be x1 plus x2, and that is divided by 2. So this is our formula to find our midpoint, and then y1 plus y2, and that is divided by 2. And that is our formula. So the point that we're looking at is, what we're comparing is from C, which is the center, which is 5, 1, and from y prime, which would be -1 and 7. So -1 and 7. So those would be our y1, y2, x1, x2. So therefore our midpoint is equal to, so our x1 would be 5 plus, or x2 would be -1, and that is divided by 2. And from our y coordinates, we have y1 would be 1 plus y2 would be 7, and that is divided by 2. So when you work that out, what you'll get is so 5 plus -1, that would give us 4 over 2, and 1 plus 7 would be 8, that is 8 over 2. So we're closer to our answer. So therefore our midpoint is equal to 4 divided by 2 would be 2, and 8 divided by 2 would be 4. So basically what these lines are telling us from the image to the center is that our object is somewhere in the middle. Our object is somewhere in the middle between these 2 points, and we're saying it is at the midpoint from our y prime. The angle for our y would be, the coordinates for our y would be 2, 4. So I'm just getting my pen. So it would be 2, 4. So let's use a different color. So it would be 2, 4. So it would be right here, which is the midpoint, the halfway mark from y prime to the center. And what we can look at now is, I'm not going to work out the rest using the formula. From x prime to y prime, this is 1, 2 units, an enlargement took place. So therefore, my original polygon, or triangle rather, it would be half of this, because remember it was enlarged by 2, which meant that this took up 2 units, which meant that my object only had 1 unit. So from this, because this is y, so from y to z, it would have only been 1 unit. From x to z, in our image, it is 1, 2, 3, 4 units, which meant that my object only took up 2 units, so it would have been 1, 2. So this is where my z would have been, because remember, all of this is enlarged by 2. So it's basically 2 units being multiplied by 2, which gave us 4 here. And this was 1 unit being multiplied by 2, which gave us 2 units here. So this is z, and this is x. So this is where my object would have been. And this is what you would draw on your exam paper. If you use the formula, the same midpoint formula, so you now take the coordinates from x prime to the center, those would be what you're now using to calculate your median. You would still get the same answer. So if that is what you feel more comfortable with, then go right ahead and do that. So now we are moving nicely along. So next we have this. It says triangle x prime, y prime, z prime is mapped onto triangle x double prime, y double prime, z double prime by reflection in the line P. State the equation of the mirror line. So basically, we're looking for a line that is exactly in the middle, in the center, which serves as a mirror, which would allow x prime, y prime, z prime to be mapped onto this triangle. So we can compare, let's say, one of the coordinates. So from y prime to y double prime, it is 1, 2, 3, 4, 5, 6 units away. So therefore, our mirror line would be exactly in the center of 6. So that would be 3 units away. So it would be 1, 2, 3. So therefore, our mirror line, it would be 1, 2, 3, is at the point, or equation would be at where x is equal to 2. So that is our equation, x is equal to 2. If you're comparing the z prime, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 units away. So it would be in the center, which would be 1, 2, 3, 4, 5. Same, x equal 2. So that is the point. Any one of the letters on your triangle that you choose to use to calculate where exactly the mirror line is, your answer would still come back to be the same, where x is equal to 2. And that is the equation of the mirror line P. So thank you for joining us, and we will see you in another video.